Hello everyone, this video is about Chapter 7, Inferences based on a single sample, Estimation with confidence intervals. Our goal is to estimate the value of an unknown population parameter, such as a population mean or a proportion. For example, we might want to know the true mean of the student GPA in our school, or the true average age of the student, or the true percentage of international students. Because of the relationship between the sample means curve and the population curve, it is possible to use the sample mean and create an interval about it to estimate where the true population mean lies. You will see that different techniques are used for estimating a mean or a proportion depending on whether a sample contains a large or small number of measurements, where we will have three different cases. Case 1. When the sample size is bigger or equal to 30, we consider it as large sample mean case, and we will use z-table. Case 2. When the sample size is smaller than 30, we consider it as a small sample mean case, and we will use another table, t-table. Case 3 is large proportion case, and we will use z-table. Now, let's see case by case. Case 1 first. Large sample mean case. When sample size is bigger or equal to 30, we will apply the central limit theorem result. That is, use the sample mean x bar to estimate the true mean. The idea is use sample mean minus something and plus something so that we will have a range or interval, and we hope the range or interval will cover the true value. The range or interval is called confidence interval. The formula is that x bar plus minus a z-score times sigma, the population standard deviation, and divided by square root of n. N is the sample size. However, most of the time, the population standard deviation is unknown, so we use sample standard deviation S instead. Here, z-score is based on how confident you are. Usually, the common confidence level will be 80%, 90%, 95%, and 99%. For example, 80% confidence level means 80% of the chance that the confidence interval will cover the true value. 99% confidence level means 99% of the chance that the confidence interval will cover the true value. Also, alpha is outside the interval. For example, 80% confidence level, alpha will be 100% minus 80% and equal to 20%. In this formula, if you have a sample, you should quickly know the sample mean x bar, sample standard deviation s, and sample size n. So in this formula, only z-score is unknown yet. Z-score actually depends on the confidence level. In summary, the confidence interval is sample mean plus and minus a z-score times the standard error. Now, let's see how to find the z-score for different confidence level. Firstly, confidence level is 80%, which means 80% of the chance the interval will cover the true value. 80% is probability, and we learn from chapter 5 that probability is area under the curve. Mean plus and minus something, so the area will be symmetric to 0. And we need to find out the z-score now. Alpha is oxide, that is 20%, and each side is 10%. So the area in yellow, which is the table value, is 40%, 0.4. We now use the z-table to search inside of the table, and the closest value to 0.4, which is 0.3997, and the corresponding z-score is 1.28. So the z-score is 1.28 for the confidence level 80%. Similarly, we can find the z-score for the other confidence level. For confidence level 90%, where alpha is 10, the area in yellow, which is the table value in z-table, is 45%. And we can find the corresponding z-score is 1.64 or 1.65. And we can use 1.65 in the future. For confidence interval 95%, where alpha is 5%, the area in yellow, which is the table value, is 47.5%, and the corresponding z-score will be 1.96. And for the confidence level 99%, where alpha is 1%, the area in yellow, which is the table value, is 49.5%, and corresponding z-score could be 2.57 or 2.58, and we can use 2.57 in the future. In summary, in the future, we can use the z-scores result which we found. That is, z equals 1.28 for 80% confidence level, 1.65 for 90% confidence level, 1.96 for 95 confidence level, and 2.57 for 99% confidence level. Lastly, after we calculate the confidence interval, we better interpret the result so that people can better understand the result. We can see that we are 80% or 90% or 95% or 99% confident that the true mean of blah blah is between your result. Case 2. When sample size n is smaller than 30, the formula is similar as case 1, but use another table called t-table to find out the t-score. Now, I will show you how to find out the t-score. In the t-table, df, which is called degree of freedom, is equal to n minus 1, where n is the sample size. In the t-table, we will look at the bottom, which is the confidence level. Rows are df, degree of freedom, equals to n minus 1. Let me give you examples. When sample size is 13, then degree of freedom is 13 minus 1 equals to 12. So you look at row 12. If confidence level is 80%, you look at the bottom and choose 80%. Then the crossing is the t-score, 1.356. Here is another example. If sample size is 24, then degree of freedom is 24 minus 1 equals 23. You look at row 23. If the confidence level is 95%, we lock the column of 95%, and the t-score is 2.069. Case 3. Large sample proportion case. This case is based on central limit theorem and binomial distribution result. Using the normal distribution as an approximation of the binomial, we can also make interval estimate of the population proportion. The formula is shown here. P hat here is the sample proportion, which is the number of successes in the sample divided by the total number sampled. Again, the z-score in this formula, you can use the result which we've just found. That is, z-score equals 1.28 for 80%, 1.65 for 90%, 1.96 for 95%, and 2.57 for 99% confidence level. Note that this formula can only be done where n times p hat bigger or equal to 15 and n times 1 minus p hat bigger or equal to 15. How to interpret the result for case 3? We can see that we are 80% or 90% or 95% or 99% confident. That's the true proportion of blah blah, or the true percentage of blah blah is between your result. Lastly, sometimes we also want to find out how many people we should interview or how many products we should select. That is the sample size problem. How to calculate sample size then? We will do the estimation for the mean first. Remember that the confidence interval is using sample mean x bar plus and minus something. This something is called sampling error or margin of error. A researcher may have a required maximum sampling error. By solving for n, we can determine the necessary sample size for the maximum error. That is, the sample size n can be calculated by this formula. Where z-score, you can choose one based on different confidence level. S here is the sample standard deviation. SE is sampling error, which you know it. Remember, you need to round up your result. For example, even 0.0001, you should round up to 1 because it is a sample size. Also, increasing the sample size will increase the accuracy of the estimate. Usually, we talk about the sampling error. We can see like this way. Within 0.5, which means the sampling error is 0.5. Or with a width no more than 2.5, which means the sampling error is 2.5. Or sometimes we will allow a confidence interval width of 3, which means sampling error will be half of it. That is 1.5. Similarly, we can also use this formula to calculate the sample size when you estimate the proportion of the population. where again you can choose the z-score for different confidence level. P hat is the sample proportion. Note that if P hat is unknown or no prior knowledge of it, we can assume P hat as half, 50%. Also, for your final result, remember to round up. Please watch the other video for examples. That's all for this video.